Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U21. For number one, if 8 minus 7 minus 6 minus 5 in parentheses is equal to 8 minus 7 minus x minus 5, what's the value of x? So here you have to distribute the negative sign across the parentheses. So when you distribute this negative sign, what you're really distributing is a -1. So there's an invisible -1 being multiplied across the three things inside the parentheses. See the same thing for the other side as well. So when you rewrite this, you can get rid of the parentheses after you use the distributive property. So on the left side, you have 8 minus 7, and the -1 combines with -6 to form +6, and then the -1 is multiplied by -5 to form +5. Again, when two negatives numbers are multiplied, it turns positive. On the right side, you have 8 minus 7. Then you have -1 times the x, which is minus x, and -1 times the -5, which is +5. So when you solve, you have 8 minus 7, which is just 1, plus 6 plus 5 is equal to 12. And that's equal to 8 minus 7, which is equal to 1. You have minus x plus 5, and 1 plus 5 is equal to 6. So you have 6 minus x. Therefore, x has to be equal to 6. -6, excuse me. So that 6 minus -6 will be equal to +12, or choice A. You can also add x and then subtract 12 on both sides. Next, for number 2, the average arithmetic mean volume of 4 containers is 40 liters. If 3 of these containers each has a volume of 35 liters, what's the volume in liters of the fourth? So average means you have to take everything, you have to add it all up. You want to divide it by the number of numbers, or the number of data in this case. So you have 4 containers, and the average is 40. So the average is equal to 40, and that's equal to the total volume divided by the total number of containers, which in this case is 4 containers. So from here, if you multiply both sides by 4, that will cancel out the 4 in the denominator, and you also have to multiply the right side by 4 as well. So it will be 160 is equal to the total volume, which we can call V. So if 3 of these containers each has a volume of 35, and the keyword is each, that tells you to multiply. 35 times 3 is equal to 105. So you already have 105 liters as the volume, but you know that the total is equal to 160. So you have to subtract 160 minus 105, and you get 55. That's choice C. So here you have to use the definition of average, which is a total divided by the number of data, and then just solve for the total and subtract. Next, for number 3, in the correctly computed multiplication problem above, if a diamond and this plus symbol are different digits, then the diamond is equal to. So here you're multiplying here, and you can just start multiplying. 7 times 5 is 35. You put the 5 on the bottom. You got to carry the 3. Then you know that 7 times this diamond is equal to, and then add 3, is equal to the symbol and whatever you carry up here. And then the next part is that you have to do 7 times that 2, which is 14. And you have to add that box, and that's equal to 18. So you know that this box has to be equal to 4. So 7 times some number plus 3 has to be 40-something. And from here, you know that 7 times 5 plus 3 is only equal to 38. So I have to try 7 times 6, and that's equal to 42 plus 3, or 45. And try 7 times 7 plus 3, that will be 52, so that's too much. So there's only 7 times 6, so that means that this diamond has to be a 6, or choice B. The problem will be 265 times 7. 7 times 6 is 42 plus 3 is 45. And 7 times 2 is 14 plus the 4 is 18. Next for number 4. If for any number n, the symbol of n is defined as the least whole number that is greater than or equal to n, then this symbol, the bracket with negative 3.7 plus 14 is equal to. So this is your function, and a function is just an input-output machine. So for this input-output machine, you have to have the least whole number that is greater than or equal to n. So you always round up, essentially. So when you have negative 3.7 in this bracket, what this means is that you'll have to round this up. And on the number line, negative 3.7 is between negative 3 and negative 4. So when you round up, you want to have the least whole number that is greater than or equal to n. That's going to round up to negative 3. So this will turn to negative 3 plus 14, which is choice E, 11. Next for number 5, how many kilometers would a cyclist travel in 1 minute if she travels at a rate of 30 kilometers an hour? So you know the rate here is 30 kilometers in 1 hour. And you want to turn this 1 hour into minutes. So you know that 1 hour is equal to 60 minutes. So if you divide by 60, you get that 30 over 60, or 1/2 a kilometer, will be traveled every minute. And then the next piece of info you can use is that 1 minute is equal to 60 seconds. Or actually, we can just stop at the minutes. We don't need to find these seconds. So here the answer will just be 1/2 a kilometer, which is choice A. Next for number 6, if DE is parallel to ST and triangle RST is an isosceles triangle, then angle E is. So DE is parallel to ST, which means that they will never meet. Now you also have triangle RST's isosceles. So for this triangle, you know that SR has to be equal to RT. So that means that the opposite angles are going to be equal as well. So you know the vertex angle, which is up here. The vertex angle is the angle that is not equal in an isosceles triangle. You can use the vertex angle to find the two base angles, which are equal or congruent. So you know that a triangle adds up to 180. So you'll do 180 minus 40. That's equal to 140. And once you do 140 divided by 2, you get that each of these angles has to be 70 degrees. Once you know that angle S and angle T is 70 degrees, because you have parallel lines, you can actually use the fact that this angle here, angle RED, is equal to angle T. And that's because these are corresponding angles. So corresponding angles are congruent. And you have that when you have sort of this letter F, or when you have this setup. So angle RED is also 70 degrees, so is angle RDE. So they really should have said RED, because angle E doesn't really exist. It has two angles there. Okay, and here's a summary for this page. Next for number 7, if 20 students share the cost equally of a gift for Coach Brown, what percent of the total do 5 of these students share? So 20% share the cost equally. That means divide. So each person will give 1 over 20. So if each person's contribution is 1 over 20, 5 of those students will have 1 over 20 times 5, or 5 over 20, which simplifies to 1/4, and that's equal to 25%. And that's choice C. Next for number 8, if n divided by 5 is equal to 150 divided by 25, then n is equal to, so 150 divided by 25 is 6. So you know that n over 5 is equal to 6. If you multiply by 5 on both sides, the n is equal to 30, which is choice D. Next for number 9, if the average arithmetic mean of -9 and s is -9, then s is equal to. So if you have the average of two numbers is equal to that same number, then s has to be equal to -9. Choice A. You can also set this up using the equation. -9 plus s divided by 2 is equal to -9. And from here, if you multiply both sides by 2, you get that -9 plus s is equal to -18. And if you add 9 on both sides, you get that s is equal to -9, the same number. Next for number 10, if x symbol y is equal to x minus 3 in parentheses times y, then 8 symbol 3 plus 5 symbol 2 is equal to. So this is your function notation. Again, a function is an input-output machine. And all you have to do is just follow the rule. So here in this input-output machine, you put x and y together into this machine, a label with a diamond. You'll do this rule, x minus 3, and then you want to multiply by y. So all you have to do is just follow the rules. So 8 symbol 3 will be equal to x minus 3, or 8 minus 3, times y, which is equal to 3. And this is equal to 5 times 3, or 15. Then for 5 symbol 2, x is equal to 5, y is equal to 2. Everywhere you see x in this rule, you replace with 5. This will be 5 minus 3. And everywhere you see y, replace this with the number 2. And that's equal to 2 times 2, which is equal to 4. So this just becomes 15 plus 4, which is equal to 19, which is choice E. Next for number 11, if 22 times 3 times r is equal to 6, then r is equal to. So your 22 times 3 is equal to 66. So that 66r is equal to 6. You can divide both sides by 66 and get that r is equal to 6 over 66, or 1 over 11 when you simplify. Next for number 12, what is the total area in square meters of two adjacent square garden plots with a side of 4 and 1 meter respectively? So you want to draw two squares. So have the square here with a side length of 4. The area is side squared, or 4 times 4, which is 16. But they also have another plot. And here this has a side of 1. So the area is just equal to 1. So you want to do 16 plus 1, which is equal to 17, which is choice D. So again, the area of a square is equal to side squared. Next for number 13, if line M is parallel to line N as shown, then angle B is equal to. So here you have parallel lines, and here you have a setup for a lot of these different angles. So first up, C and 120, these are supplementary angles. So supplementary just means a straight line, and that's equal to 180 degrees. So this would be 180 degrees. So you know that C plus 120 is equal to 180. C would be equal to 180 minus 120, which is equal to 60 degrees. Now, once you know that angle C is equal to 60 degrees, angle C and angle A are equal because these are corresponding angles. And corresponding angles form this letter F. And when you have parallel lines, the corresponding angles are equal. So you see this letter F here. Now, next up, to get angle B, angle A and angle B are also equal because A and B are opposite angles or vertical angles. And opposite angles or vertical angles, they form this letter X, and they are equal. Now, the other thing that you can do is angle B and angle C. Angle B and angle C are alternate exterior angles. And they are also equal. So when we have alternate exterior angles, they're on the outside of the alternate interior ones, so they're also equal as well. So here you have a lot of vocab. You have corresponding angles, opposite or vertical angles, alternate exterior angles, also supplementary or straight angles. You need to know all of them to solve this question. And here's the summary for this page. Next, for number 14, if 6m over 9 is equal to 4, then 18m is equal to. So here you have 6m over 9 is equal to 4. And here you can actually cross-simplify the 6 and the 9 in the denominator cancels to form 2/3. So you really just have 2/3 of m is equal to 4. And from here, you can multiply both sides by 3/2. The reciprocal to cancel out the 2 and the 3. So you get that m is equal to 2 times 3, or 6. Now, once you know that m is equal to 6, you can substitute back in to solve for 18m. So 18 times 6 is 108, choice E. So just be careful here, the answer is not A. So one thing to keep in mind for this, when you have a fraction, 6m over 9, you could rewrite this as 6 over 9 times m, or 6m times 1/9. So there's a lot of ways that you can split this fraction. As long as 6 and m are in the numerator and 9 is in the denominator, you can rewrite this in a variety of ways. Next, for number 15, during a local high school track meet, all 3 contestants earn points. Olivia earns 12 more points than Barbara, and Diane earns 8 more points than Barbara. What's the ratio of Diane's points to Olivia's points? So here we wanted to set up a system of equations. Olivia earns 12 more than Barbara. 12 times more means times 12. So O is equal to 12 times B. And then Diane earns 8 times more than Barbara. So again, 8 times means multiply. So Diane, which is D, is equal to 8 times B. So here you want to figure out the ratio of Diane to Olivia's. And ratio means divide. Or you can use a colon symbol. So Diane to Olivia. So here, you know that Diane is equal to 8 times B. And you know that Olivia is equal to 12 times B. So when you do the ratio of 8b to 12b, you can rewrite this as 8b over 12b. B will cancel out, and 8 over 12 simplifies to 2/3 if you divide by 4. So the answer is just choice D, 2 to 3. The variable B, or Barbara's points, gets canceled out, whatever that number is, and you know that the ratio has to be 2 to 3. We don't know their actual points, but we do know that the ratio is always going to be 2 to 3. Next, for number 16, you have if x squared minus z squared is equal to 130 and x minus z is 10, then x plus z is equal to. So this is your difference of two squares factoring pattern. And for your difference of two squares, a squared minus b squared, it can always be factored as a plus b times a minus b. And here you can test it out by just factoring a plus b times a minus b. So you have a times a, which is a squared, that's the first. And the outer is a times negative b, or minus ab. The inner and the last are b times a, or ba, and a b times negative b, which is minus b squared. And here the middle two terms are the same, but just opposites, they cancel out. So you just get a squared minus b squared. So from here, you can just turn this x squared minus z squared as x plus z times x minus z. That's equal to 130. And that x minus z is 10. So that means that x plus z times 10 is equal to 130. So if you divide by 10, you get that x plus z has to be equal to 13. That's choice B. So this would be a lot easier than substituting, because you would then have to isolate a variable, then substitute in and factor, and that's a lot of work. If you use a difference of two squares factoring pattern, it does save a lot of time. Next, for number 17, in the figure shown here, what does x equal? So you have this triangle and a whole bunch of these different angles, and x is over here. So first up, you have this angle ABD, that's supplementary, because it's a straight line, and supplementary equals 180 degrees. So you do 180 minus 120, you get 60. So once you know the angle CBD is 60 degrees, and then you can use the fact that you have a triangle here, and this triangle adds up to 180 degrees. So you have 50 plus 60, and that's equal to 110. Then 180 minus 110 is equal to 70. And then the next piece of info you'll have to use is that this angle here is also supplementary, also equals 180 degrees. That means that x plus 30, the left angle, plus 70, the right angle, has to be equal to the angle on the right, I should say. It's equal to 180 degrees. Here, 70 and 30 are like terms, so x plus 100 is 180. And if you subtract 100, you get that x is equal to 80. And that's choice A. So here you have to use supplementary, as well as the fact that a triangle adds up to 180 to help you get to the answer. Next, for number 18, in triangle ABC, angle ABC is 53, BCA is 37, and BC is equal to 5, and AC is equal to 4. What's the length of the shortest side? So here you have this triangle. So you don't know what this triangle is, so let's draw it. So angle ABC, which is over here, this is 53. Angle BCA is over here, this is 37. So again, a triangle adds up to 180 degrees. So if you do 53 plus 87, or 37 rather, not 87. Okay, so 53 plus 37, that's 90, and 180 minus 90 is equal to 90. So this is actually a right triangle. And when you have a right triangle, where A is 90 degrees, you can use Pythagorean theorem. So in this case, AC is equal to 4, and BC is equal to 5. And here, this is your 3, 4, 5 special right triangle. So because it's a right triangle, use Pythagorean. Where the square of the two legs, and you add them up, that's equal to the square of the hypotenuse. Or you can use the triplets. So the triplets that you need to know are 3, 4, 5, and 5, 12, 13, and includes the multiples. Here we have the 3, 4, 5, so you know the shortest side has to be choice B, 3. You can also set this up using Pythagorean. If you don't know what the 3 is, you can call that equal to a. So you have a squared plus 4 squared is equal to 5 squared, and a squared plus 16 is equal to 5 squared, or 25. Subtract 16 on both sides, you get that a squared is equal to 9. So a has to be equal to 3. Next, for number 19, if 22 is the average of n, 15, and 35, then n is equal to. So here's another average question. And remember, average is the total divided by the number of data. So 22 is equal to the total. So you have to add those 3 numbers up. N plus n is 3n. That's 3n plus 15 plus 35. And I want to divide this by 5 because you have 5 numbers. And from here, you can multiply by 5 on both sides. And then 15 plus 35 is 50. And from here, you can subtract 50 on both sides to solve for n. You get that 60 is equal to 3n, and you divide by 3, you get that n is equal to 20. That's choice C. Now you can also check your work. So you want to find the average of 20, 20, 20, 15, and 35. If you add everything together, the total will just be 60 plus 50, or 110, divided by 5. That's equal to 22. And that's the average. Next, for number 20, if 7x plus 18 is equal to 16x, then x is equal to. So from here, you want to subtract 7x on both sides, just using inverse operations. Get 18 on the left is equal to 16x minus 7x, which is 9x. And if you divide by 9, you get that x is equal to 2. And that's choice D. Okay, and here is the summary for this page. Okay, for the next page, you need to compare 2 different quantities. You choose A if A is bigger, you choose B if the thing in column B is bigger, C if they're equal, and D if you if you can't tell. So for number 1, these 2 rectangles are congruent, and you want the area of triangle A and B, and then the area of triangle LEF plus KFG. So from here, you know that the area of a triangle is 1/2 base times height. So I don't know what the height is, so you can just call the height H. And I don't know what the base is, so you can just call that B. So on the left, the area of A and B is just 1/2 base times height. Now because they're congruent, the height is still H for the triangle on the right, and the base is still B, but B got split into 2 different pieces. So we can call that, let's say, X and Y. You know that X plus Y has to be equal to B. So for the 2 triangles, triangle LEF, the area will be 1/2 the base, which is X, times the height, which is H. For the triangle on the right, you have 1/2 Y times H. You want to add them up. So when you add these 2 triangles, these 2 areas up, they turn out to be related to 1/2 H. So you have 1/2 H, that's the same, because you have 1/2 XH plus 1/2 YH. If you factor out 1/2 H, you get that 1/2 H gets factored out, and what you have left over is X plus Y, which you know is B. So it turns out the 2 are the same. So the answer is C. Next, for question number 2, it says A is greater than 0, B and C are also greater than 0. If AB is equal to 2, BC is equal to 8, and A times C is equal to 8, 2, 9, and 8, excuse me, what is the difference between A, B, and C in column A versus 14? So here, they're all positive. And you know A times B, B times C, and A times C, so you have 3 equations and also 3 variables. So you can solve for all of them. You can use substitution or elimination to solve for any of the individual variables. However, we actually don't need to solve for any of the individual variables. We only need to solve for the product of A times B times C. So here, if you take a look at these equations on the left side, if you multiply everything together on the left side, you actually get A squared times B squared times C squared. And on the right side, you have 2 times 9 times 8. So we're going to use a variation of this elimination method where you can actually multiply the left side of all the equations and multiply everything on the right side. So then A squared times B squared times C squared is equal to 2 times 9, which is 18, times 8. Which is equal to 144. Now, once you know that, then you can do the square root on both sides, which will actually simplify everything to just A times B times C, which is equal to the square root of 144, or 12. So here, when you're comparing 12 to 14, 14 is going to be larger, so the answer is going to be B. Next, for question number 3, the 3 circles are externally tangent to one another. The radii are 4, 5, and 7. So tangent is a key word here. Tangent means that these two things meet at exactly one point. So when a circle is tangent to another, they meet at just one point. So they are touching only at this point, and this point. And now the radius, are 4, 5, and 7. So B is the smallest, C is in the middle, and then A is the largest. So here you can actually figure out the perimeter of triangle ABC if you just add 7 plus 7 plus 4 plus 4 plus 5 plus 5. That's 14 plus 8 plus 10, or 22 plus 10, which is equal to 32. And that is greater than 30. So the answer is A. Next, for number 4, you have to solve this really big expression in column A versus 399 in column B. So on the left side, you see that all the denominators are the same. So you see that the LCD is 399. So you just multiply the numerators, and then you have to square the denominators as well. So here you have 20 over 399 squared plus 14 over 399 squared plus 6 over 399 squared. And that's a numerator. And if you add the numerators, you get 40 over 399 squared. The denominator, you also multiply 2 times 4 times 5, which is equal to 40, but it's over 399 cubed. So when you have a complex fraction, you can rewrite this as a division problem. So you just have 40 over 399 squared divided by 40 over 399 cubed, and then you can use keep change flip to turn this into 40 over 399 squared times the reciprocal, which is 399 cubed over 40. And the 40 cancels out, and 2 of the 399s cancel out, and you have just 399 left. So everything on this left side is just equal to 399, which is going to be equal to 399, so the answer is going to be C. So you use the LCD to rewrite the numerator and the denominator, and then you have a complex fraction. And to solve a complex fraction, you just rewrite using this division symbol and keep change flip. Next, for number 5, 6 is 6 over 5% of y. So here you can turn the word sentence to a number sentence. Is means equals to, of means times, and percent means divided by 100. So you know that 6 is equal to 6 over 5, and you're dividing this by 100, and then you're multiplying it by y. So 6/5 divided by 100 means 6 over 5 times 1 over 100 when you keep change flip. So then when you simplify this, you know that 6 is equal to 6 over 500 times y. So to solve for y, you'll have to multiply by the reciprocal on both sides, which is 500 over 6. So when you do that, on the right side you just have y, and on the left side, the 6's cancel out, and you just have 500. So you know that y is equal to 500, and that's always going to be greater than 400. So the answer number 5 is A. Next for number 6, you have this equation. So 4 plus 4 over 4 plus 4 over 4, that's really just 4 plus 1 plus 1 is equal to z. So that means that z is equal to 6. Or rather, you have some decimals there. So they're not just equal to 1. So we have 4 divided by 0.4. You move the decimal over. That's really 40 divided by 4, which is 10. And we have 0.4 divided by 4. That's just, if you divide by 4, you get 0.1. So that's 14.1 is equal to z. And 14.1 is greater than 13, so the answer is A. Just be careful of the decimal points there. Okay, and here is the summary for this page. Next for number 31, you have 1 cubed plus 2 cubed plus 3 cubed all the way down to 2000 plus 2001 plus 2002 cubed is equal to n squared. The sum of the first 2002 cubed is the square number n squared. What does n equal? So here when you're cubing everything and then you're squaring them, you want to see what n is equal to. So for this question, you really just need to find a pattern because there's no way you can add all the numbers up to 2002 cubed because that's just too many. So when you look for patterns, for example, with square numbers, that's actually the pattern on the times table. When you have 1 squared, 2 squared, 3 squared, 4 squared, this is of course the diagonal on the times table. And if you draw some squares, you can actually see a pattern with the odd numbers. So for the first dot here, that's 1 squared. And when you get to 2 squared root of 4, you make a 2 by 2 square. So you have to add 1 plus 3. And then when you get to the third number, 3 squared, which is 9, you have to add 5 more dots. So that's going to be 1 plus 3 plus 5, because here this is 5. And then next up, for 16 or 4 squared, you have to add 7 more dots. And the 7 comes from this. So when you get to the n square number, you're really just adding 1 plus 3 plus 5 plus 7 all the way up to that number n. So that's a pattern for square numbers. For cubic numbers, you have a similar pattern with odd numbers as well. Remember, for cube, instead of having just a flat square, you have a 3-dimensional shape. So this will just be multiplied that many times as well, because it's just a third dimension. So with cubic numbers, so to start with this pattern for cubic numbers, you can model this with smaller cubic numbers. You start out with the perfect cubes. The first, of course, it's 0, which is just 0. Then when you have 1 cubed, you got 1. 2 cubed is 8. And 3 cubed is 27. And 4 cubed is 64. So if you want to get the sum for the 0th cube, or for the first cube, so the first, let's say the first cube, of course, is just 1. Then if you have 1 cube plus 2 cubed, the first 2 cubes, this would be 1 plus 8, or 9. And then the first 3 cubes will be 1 cubed plus 2 cubed plus 3 cubed. And 1 plus 8 plus 27 is 9 plus 27, which is 36. And then the first 4 cubes will be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. That's 36 plus 27, or excuse me, 64 plus 27, which will be sorry, 64 plus 36, which will be 100. There we go. So you kind of see a pattern here. The first cube is just 1 cubed. Then the first 2 cubes is 3 cubed. Then for the first 3 perfect cubes, that's 6 cubed. And then when you add the first 4 cubes together, that's equal to 10 cubed. So you kind of see a pattern here when you have, well, normally the 0 cube is just 0. So you have plus 1, then plus 2, then plus 3, then plus 4, etc., etc. So there's the pattern when you get to eventually the 2002nd perfect cube. So 1 cube plus 2 cubed plus all the way up to 2002 cubed. You're going to be adding numbers all the way up to 2002. So to figure out the sum of all of these numbers, to figure out what that perfect cube is, you have 1 plus 2 plus 3 plus 4, and you're adding 2001 to 2002. So here, because you have a consecutive list of numbers, you can just pair them up using the rainbow method. You'll have each pair is 2003, and specifically you have 1001 pairs of 2003. So if you multiply 1001 times 2003, you get that the 2002nd cube will be the sum of the first, 2002 cube numbers, which will be 2,005,003 cubed, and that's choice B. So for this one, you just have to find the pattern, and once you find the pattern, you can then use that pattern to model it for the larger number, and then just continue the pattern until you get to the first 2002 cubes. Next one, number 32, ABCD is a 2 by 2 centimeter square. Points E, F, G, and H are the midpoints of the sides of the square, and in square centimeters, what's the area of the region AEPQ? So AEPQ is this region here, and I want to figure out the area of that region. So for this question, it might be better to first draw this to scale because E doesn't look like a midpoint. So to draw this to scale, you have to connect the midpoints, which are just the middles of each of the edges. And you basically just connect it to the corners. So because you have a square and you're splitting this into smaller sections, turns out you just made another smaller square in the middle. And you can actually prove this by setting up a coordinate system in which you call D the origin, 0, 0, and because the edges are 2, B would be 2 comma 2, H would be 0 comma 1, A would be 0 comma 2, G is 1 comma 0, C is 2 comma 0, and F is 2 comma 1. So you can actually find the slope of this line, which is change in y over change in x, and that's 1/2. And then you would have to find the slope of this line here, and the slope would be change in y, or 2 minus 0 divided by 0 minus 1, and that's 2 over negative 1, which is negative 2. And negative 2 and 1/2, these are negative reciprocals. And when you have lines with negative reciprocal slopes, they are perpendicular. So therefore, this is a square in the middle. So once you know that this is a square, it makes things a lot easier, because then you can draw a bunch of right triangles. And once you have right triangles, you can use Pythagorean theorem. So that's what you're going to have to use, Pythagorean theorem. Applies for all right triangles, and it states that a squared plus b squared is equal to c squared for a right triangle. So here you have a bunch of right triangles. For example, this large one, the side is 2. The bottom, because it got cut by a midpoint, it's just 1. So this distance here would be 1 squared plus 2 squared. And the square root of 1 squared plus 2 squared is the square root of 5. You can do that on the side. And c would be the square root of 5. So once you have this piece, then all the other sides are also root 5. And when you have that, you can actually see some symmetry, and you'll be able to find the smaller triangles, which are also similar. So, for example, this smaller triangle up here is a right angle as well, and it's actually similar. This triangle is similar to this larger triangle because it shares the same angle here, and it has a right angle. So that means that for this smaller triangle, the hypotenuse is equal to 1. So because you have similar triangles, the sides are in a ratio. So for the larger triangle, it's a 1, 2, square root of 5. For this smaller triangle, it will be proportional to that. The larger triangle will be 1 to 2 to root 5. That's the hypotenuse. For the smaller triangle, the hypotenuse is equal to 1, so you just have to divide everything by root 5. So the shorter side is 1 over root 5, and the longer leg is 2 over root 5. And this applies to all the red triangles here. So once you have all of that written out, you can actually see that this region up here, which is equal to this region and this region and this region, any of them will work. You can split into 2 pieces. Specifically, it'll be a rectangle with a right triangle. Now for this smaller right triangle that I have in black, it's actually the same as this red triangle. Again, when we draw it to scale, it's much easier to see. But you have this right angle here. You have the same angle because these 2 lines are parallel. So these are corresponding angles. And then this angle up here is also equal to this angle up here. So everything is the same. So you essentially have this weird shape broken down into 2 shapes. This rectangle, and the area for this rectangle is just base times height. And the base is 1 over root 5. And this piece will be 2 over root 5. That's the same here. So when you multiply this together, you get 2/5. And then for the smaller right triangle, the base is 1 over root 5. The height is 2 over root 5. So the area will be 1/2 base times height, which is 1/2 1 over root 5 times 2 over root 5. Here the 2 cancels out, and the root 5 and root 5 just becomes 5. So the smaller triangle has an area of 1/5. So when you split this up, this piece is 2/5, and at the top piece is 1/5. So when you add everything up, you'll have choice A, 3/5. And that will be the area for this section. So this was a little challenging only because the original shape was not drawn to scale. If you draw this to scale, it becomes very symmetric, and you can use Pythagorean theorem, a squared plus b squared equals c squared, as well as similarity, so similar triangles to help you determine that you have a whole bunch of congruent right triangles, and then you just split this up into these congruent right triangles and also these rectangles here. So we essentially have these equal rectangles, and all these are congruent right triangles. And then, of course, you have that square in the middle. So because the original was a square, you can see that there's a lot of symmetry here. Next, for number 33, how many ordered pairs a comma b of whole numbers are solutions of a cubed plus b cubed is equal to 2002 cubed? So here, when you have ordered pairs, and they have to be whole numbers, and they have to be solutions of this cubic function. So when you have a cubed plus b cubed, you can try to factor this. So for this question, of course, you're not supposed to do 2002 cubed, because there's a whole bunch of numbers between 1 and that number. But what you can do is to use the properties of cubic functions, specifically the perfect cubes. A cubed plus b cubed can be rewritten as a plus b, or factored as a plus b, and you have a squared minus ab plus b squared, and you have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So you can use either one of these, but we don't know what one of these numbers are, so it's actually helpful to subtract b cubed from both sides. That way we have a cubed is equal to 2002 cubed minus b cubed, and we know that a cubed must be a whole number. So that's just a times a times a. And then on the right side, you can use this difference of two cubes to rewrite this as 2002 minus b times 2002 squared plus 2002b. And then you want to add b squared. And now this should be equal to a times a times a. So a couple things could happen. Either a could be prime, or a could be composite. Either way, you're going to see that there are no whole number solutions for this, because if a is prime, then you can't break down a anymore. And that means that for these two numbers, because you have a product of just two numbers, this number times this number, this can't be a and this can't be a times a. There is no way to go from the factor on the left, 2002 minus b, into this factor. If you squared it. If you squared 2002 minus b, you won't get this factor. Now, that's if a is prime. But even if a is composite, and we can break down a into smaller numbers, you can actually see that even if we break it down to smaller numbers, let's say b times, or let's say x times y. If you pick one of these numbers, let's say x, the other numbers here have to be a factor of x, because they must have x as a factor in it. And we see that that can't be true. You can't have one number to be x, and the other one will be x times y times x times y times y. Because this doesn't have any factors of this, and vice versa. So here there's a contradiction. A can either be prime or composite, because it has to be a whole number, and we see that it can't be either prime or composite, because these two have no common factors at all. So it turns out that when you have a squared plus b squared equals c squared, that's for Pythagorean, that works for a whole bunch of numbers, your triplets. But if you try this for a cubed plus b cubed equals c cubed, it only works for a couple of numbers. So like 1, for example. It doesn't work for anything greater than 1, it won't work. So there are choice A, no solutions, because we don't have any factors here. Next, number 34, how many different 3-letter arrangements of letters, SIS, PMI, IMP, etc., can be made from the letters in Mississippi? If you just count how many letters you have in Mississippi, you have a lot of repeats. For the letter M, you have 1. And for the letter I, you have 1, 2, 3, 4. For S's, you have 4. And P's, you have 2. So when you're rearranging these letters, you can't repeat any of them, which means you can't use any of the letters twice. So this is just a tree diagram question. So for the first letter, you can choose M, I, S, or P. So you have 4 branches there. But then depending on what you choose, each of these branches will be a little different. For example, if you choose M, you can't choose M again because there's only one M. You can only choose I, S, or P. And then if you choose I, you can choose, for the third letter, I, S, or P again. Again, you can't choose M because M was already used. And because you have 2 P's, you can choose another ISP. So here, for the M branch, you have 9. And then for the I branch, if you choose I first, you can choose M, I, S, or P. Because you have, you still have the M left, and you still have 3 I's available, so you can choose I again. And then if you choose M, you can't choose M again. So this M branch, you only have I, S, or P left. But if you have I and then another I, you have another 4 branches, M, I, S, P. And same for the S's and same for the P's. So you have 12 here plus another 3, or 15 branches if you choose I first. And then for S, if you choose S first, there's still enough to go with 4 branches, M, I, S, P. But again, the M branch is tricky because if you choose M second, you can't choose M anymore, so you can only choose ISP. For the other letters, you can choose MISP. So you have 4, 4, 4 for 12 plus another 3, that's another 15. And now when you get to P, it's also a little tricky because first you can choose MIS or P. But if you choose M, you can't choose M again, so you can only go with ISP. If you choose I, you have all 4 options available. Same for S. But if you choose P second, you ran out of P's, so you can only choose M, I, or S. So in this case, we have 8 branches here, 3 and 3. So 8 plus 3 plus 3 will give you a total of 14 branches. So if you add the 4 numbers here, 9, 15, 15, and 14, you get a total of 53, which is choice D. So this is just your tree diagram question. Just be careful because there are some repeats. For question number 35, how many triangles of any size can be found in a diagram shown? So just define triangles, and there are some overlapping triangles, so you want to keep some order here. So for example, you could first find the ones that are just single triangles. So you have 1, 2, 3, 4, 5. There are 5 triangles that are just, by themselves. Then you want to find the triangles that have 2 in the middle. So there's 2 triangles. And for those, it helps if you count them by the line separated the 2 triangles. So there's one here for those 2 triangles. Then there's a line here for those 2 triangles. You can have this line, that's 3. This line will be 4. So you have 4 of these triangles that are just pairs. Then this line is 5. This line is 6. So those 2. And I think that's it. So there's 1, 2, 3, 4, 5, 6. Or so far there's 6. And, there's actually more. One here for these 2 triangles. And this one. So there's actually 2 more. So that's going to be 8. So far we have 8. And I think that's all the lines that you have. Then you want to find the triangles with 3. So there's this one on the bottom, this one on the right. So that's 1, 2. And then you have 3 and 4, for those 3. And then also 5 and 6. And then from there, so let me just mark them again. You have 1, 2, 3, and then 4, 5, 6. For those triangles, I don't think there are any more. To have those 6. And then after that, you have triangles with 4. They're made up of 4 pieces. So it helps if you find the corners here. So you have this for this triangle. This corner for this triangle. You have this corner for this triangle. And that's just 3. So you have 3 of those triangles with 4 pieces in it. Then you want to find the triangles with with 4 pieces in, Then for triangles with 5, there aren't any triangles with 5 pieces, but you do have some triangles with 6 pieces. So this triangle here, for example, has 6 pieces in it. So there's one triangle here, another triangle on the left side, and also this triangle here, and also this triangle here. So you're really counting these 6 pieces by something that looks like this line in the middle. So you have this line, this line, this line, and this line. And that's what makes the triangles with 6 pieces inside. So you have 4 of those. And then you're done with the 6 pieces. You don't have any with 7. And there's, of course, the whole thing, which is just 1. So if you add everything up, 6 and 4, that's 10. 8 and 5 is 13. And then you have 1 and 3, which is just 4. That's a total of choice E, 27. So for this problem, you just have to organize and make a chart and just be careful and make sure you don't double count. Next, for number 36, what's the value of this expression with 2001 terms? Notice that every third term is subtracted. So if every third term is subtracted, what you're adding here is, or what you can do is you can, because there's a pattern, you just keep increasing by 1. You can pretend that you're adding all the numbers all the way down to 2001. So if you count the number of numbers, you have 2001 numbers. And when you get to the pairing, each of these pairing is 2004. Or sorry, 2002. So because they have 2001 numbers and each pair is 2002, if you take 2002 multiplied by the number of numbers and you have to divide it by 2, because there'll be one number in the middle, but in terms of the average, you just divide it by 2. This will give you 1001 times 2001, which is going to represent the total from 1 to 2001. So 1001 times 2001 is 2,003,001. Now, the problem with this is that every third number is subtracted. So here you have to first undo those third numbers and you have to subtract that again. So this assumes that all the third numbers are added, but when you add 3 plus 6 plus 9 plus 12 all the way down to 2001, you'll have to subtract the sum twice to get the sum that's written here. So when you add here, 2001 divided by 3 is 667. So this is the 667th odd number, or multiple of 3. So you'll have 667 numbers. And again, you do the pairing. This time each of the pairs adds up to 2004. So you have 2004 times 667 divided by 2. And that's 1002 times 667. That's equal to, so this is equal to 668,334. So that's just the negative terms. Now when you take this total sum, if you added everything, and you subtracted just the negative terms, these negative terms here, you just got the sum of just the positive numbers. So 1 and 2, 4 and 5, 7 and 8, etc. So you need to subtract 2 times 668,334. You subtract once to get just the positive terms, and then you subtract again because you have negatives in between every third. So if you double 668,334, so 668,334 times 2, and you subtract 2,003,001, you get 666,333. And that is choice B. So here's the summary for this page. Okay, next, for number 37, the numbers 1 through 16 are entered into a square grid with 4 rows and 4 columns. The sum of the numbers in each of the columns is the same. So what is the sum? So the columns have to be the same, and when you're adding the numbers from 1 to 16, so eventually you have to add everything together. So if you add all the numbers from 1 plus 2 plus 3, all the way down to 14 plus 15 plus 16, if you have the total here, you can just divide that by 4 because the sums have to be the same. So here you have, again, you've paired them up. You have 8 pairs of 17. So 17 times 8 is 136, and you could just do 136 divided by 4. And when you do 136 divided by 4, you have 34. So that's choice D. Next, for number 38, a fox is pursued by a hound, and the fox starts 63 of her own leaps ahead. The fox makes 4 leaps. Each time the hound makes 3 leaps. The hound in 5 leaps travels the same distance as the fox in 9 leaps. The hound does catch up to the fox. From the start until the fox catches the hound, what is the sum of the number of leaps that both animals take? So the fox starts 63 ahead, and it makes 4 leaps. Each time the hound makes 3 leaps. So here you have the rates. So for the fox, you have 4 jumps, and the hound has 3 jumps. So this is the rate. Essentially, the hound is 3/4 the speed of a fox. So the fox speed, we can call that R, the rate of the fox. The hound's speed will be 3/4 of the fox. So 3/4 of R, because 3 is 3/4 of 4. And then here, in terms of the distance, the hound leaps 5 times 5 jumps, the same as the fox's 9 jumps. So in terms of the distance, 5 of the hound leaps, so 5 of the H is equal to 9 of the foxes, 9F. So in terms of each of the leaps, if you divide by 9 on both sides, one of the fox leaps, F, the distance for the fox leap is equal to 5/9 the hound leap. So the hound is jumping more than the fox. Now the hound does catch up to the fox, so from the start until the 2 meet, what's the number of leaps that they both take? So for this question, you want to first figure out the timing first, because for the timing, over here, the fox will make 4 jumps when the hound makes 3 jumps. So we don't have a time for that, so we can just pretend that's 1 second, just so that we can equate the two. So in 1 second, let's say the fox makes 4 jumps, and the hound makes 3 jumps. That means that the fox will make a jump every 1/4 seconds, or 1/4 seconds will be 1 jump. And for the hound, it's 1/3 of a second, just so that we can relate these two quantities. And again, it's this relation. In reality, should use the variable R, but we could just make R equal to 1/4, for example. So here, when you have these rates for the fox and the hound, you have the timing. So in terms of the time, you know that the fox starts out 63 of her own leaps ahead. So for the fox, you have a head start. It's 63 jumps. And you'll be adding 4 jumps every second. So that's using this unit rate. You could say 4J. That's per second. So again, here you have 63 jumps ahead plus another 4j jumps per second. And for the hound, you don't have head start, so you start out with 0 jumps, and you're jumping 3j per second. And again, that comes from this part here. And this is hound jumps. So then you start bringing in the next quantity, which is the distance. Because each time you jump, you also jump some distance. In this case, we're going to use the fact that a fox will jump 5/9 the distance of a hound. So this gives you the number of jumps for each of these seconds. And if you multiply this by h, because the hound will jump h distance every jump, the fox will only jump 5/9 of h. You'll be multiplying this by 5/9 of h. So this will give you the total number of jumps in terms of h. And this is actually what allows us to set these equations equal, because at some point they'll catch up. The distance that they jump will be equal, which means they caught up. So you have to distribute this 5/9 of h to 63 and 4j. So you have 5/9 of h, and you're distributing it to 63 plus 4j, and you're setting this equal to h times 3j. So now I have an equation. This is a lot easier. We can first cancel out the h. So the h is gone. So when you distribute 5/9, you have 5/9 of 63 plus 5/9 of 4j, and that's equal to 3j. So the 9 and the 63 cross cancels, and you have 7, so this will be 35. And here you have 20 over 9j is equal to 3j. And you can move the 20 over 9j to the other side by subtracting. So if you start with 35 plus 20 over 9j is equal to 3j. If you subtract 20 over 9j, 3j you can rewrite as 27 over 9j. Then we have 27 minus 20, that's 7 over 9 jumps is equal to 35. And the last step, you can multiply by 9 over 7, the reciprocal on both sides. And you get that the jumps is equal to 45. So once you know that j is equal to 45, you can see that the fox will jump 4 times that, and the hound will jump 3 times that. Specific over here. So 3j plus 4j is equal to 7j. So you just have to do 7 times 45. And when you do 45 times 7, that's equal to 315, choice D. So all in all, they jump 315 times. Next, for number 39, how many triangles can be found in the diagram below? So this is pretty much a bigger version of number 35. And there is a pattern here, so you can count all of them, but that's way too much work. If you actually start with this triangle here, you can see the pattern. You're just stacking a lot of triangles on top of each other. So you have this triangle here, and then you have 2 stacked, and then here you have 3 stacked. So let's see if there's a pattern. So the first shape would be just a 1 stack, and here just 1 triangle. Then when you take that 1 triangle and you stack another one up, here you have more triangles that can be made. So this is a 2 stack. And in this 2 stack, you can see, of course, there's individual triangles. You have 1, 2, 3. And then for the pairs, you have 1, 2, 3, and 4. So here again, you can count the number of lines here. So there's 1, 2, 3, 4. That will make the 4 triangles. And then finally have everything together. So if you add 3 plus 4 plus 1, you get 8. And then when you have 3 stacks, which we already did, you get 27. So you see a pattern, it's 1 to 1, and then 2 to 8, and then 3 to 27. So the pattern here is that you're essentially cubing. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So if you just count the number of stacks here, you have 1, 2, 3, 4, 5, 6 triangles stacked on top of each other. So when we have 6 stacks, this will be 6 cubed, which is equal to 216. So that's going to be the shortcut here. Next, for number 40, the new census taker has been told that Miss Math always answers truthfully, but not always clearly. With great fear, the census taker knocks on Miss Math's door. When she opens his door, she asks, "How many children do you have?" She responds, 3. He continues, "What are their ages?" And she answers, "The product of the age is 90, and the sum is the address of my house." The census looks at the house number and complains, "That's not enough information. Do you have a 1-year-old child?" Miss Math responds truthfully. He says with release, "Thank you. Now I know their ages." What is Miss Math's house number? All of the ages are whole numbers. So for the census taker problem or riddle or whatever you want to call it, here you have a product of the ages is 90. So you don't know the children. So you can have A times B times C is equal to 90. And the sum is the address. So A plus B plus C equals the house number. Now, because the product is equal to 90, you need to know the factors of 90. So for 90, you have 1, 90, 2, 45, 3 with 30. 4 doesn't work. You have 5 and 18, and 6 with 15. 7, 8 doesn't work, and you have 9 and 10. And then you just kind of list out the potential factors. So you just start with 1. You can have 1, and then you have to figure out the 90. So the 90, you can have all these different factors of 90. So you can have 1, 2, 45, 1, 3 with 30, 1, 5, 18, 1, 6 with 15, and 1, 9 with 10. Okay, and then for the 2s, you'll need the factors of 45. So for 45, you have 1, 45, 2, and, or sorry, not 2, 3 and 15, then 5 and 9. Then you don't have 6, 7, or 8. So that's it. So then for 2, you can have 2 with 145, which you already have here, so you can delete those. Or 2, 3, 15, and then 2, 5, and 9. And then for the next one, you can have, so with those 2, you can have 3 with 30. So you'll need the factors of 30. So 30 is 1 and 30. 2, 15, 3 and 10, and 5 with 6. So you can also have 3, 1 and 30, which you already have. 3, 2 and 15, which again you already have. So you can have 3, 3 and 10, and 3, 5 and 6. Okay, so done with 3s. Then you move on to 5s and 18. So then you'll need the factors of 18. You have 1 and 18, 2 and 9, 3 and 6. So you can have 5, 1, 18, which again you already have. 5, 2 and 9, which comes over here. Then you can have 5, 3 and 6, which you already have over here. So you don't have any new ones with 5. And then with 6 and 15, you'll need the factors of 15, as well as 6. Because 6 you can have 2 and 3, 1 and 6. And with 15, you have 1, 15, 3, and 5. So here, if you have 6 as one of the factors, you can have 6, 1, and 15, which you have here, and 6, 3, and 5, which is over here. And even if you were to break down the 6 into 2 and 3, you would have the other factors here or here. So again, you don't have any new ones there. And then finally with 9 and 10, same thing, if you break down 10 as one of the factors, you can have 10, 3, and 3, or 10, 9, 1. So here are all the triplets for the factors of 9, and then all you have to do is add up the numbers. So the house number could be 48. This would be 30 plus 4, 34. This would be 18 plus 6, 24. This would be 1 plus 21, or 22. This would be 20. This would be 20. This would be 2, 5, and 9, which would be 16. Here, 3, 3, and 10 is 16. And 3, 5, and 6 is 14. So you have all of these potential sums. And here we actually can cross out some of these numbers. And the reason we can cross out some of these numbers is because the census taker looks at the house number and says that's not enough information, which means there has to be a double or duplicate. For example, if the house number was 48, then there's only one combination that will give you a sum of 48, 1, 2, and 45, and the census taker would be done. So it can't be 48, it can't be 34, it can't be 24, it can't be 22, or 14. So the only two can either be 16 or 20, because you do have two duplicates here. 1, 9, and 10 add up to 20, and they multiply to 90. 2 times 3 times 15 multiplies into 90, and they add up to 20 as well. And alternatively, you have 2, 5, and 9, which multiplies to 90, but they add up to 16, as well as 3, 3, and 10, which multiplies to 90 and adds up to 16. So you have these possibilities. So you can eliminate A, eliminate D, and eliminate E. So you just have B and C left. Now, to solve for this, the difference between these two is, do you have a 1-year-old child? So when you answer that question, he says, thank you, now I know their ages. So here, if you say yes, you do have a 1-year-old, you know it has to be this. If she says no 1-year-old, then the census taker would need to actually ask another question, because you still don't know what the answer is. Because you still could have 16 or this. You could still have 2 or 3 or 5 or 9. So because he was done after Ms. Math says yes, and there was no need for a follow-up question, we know that the answer to do you have a 1-year-old has to be yes. But again, that wasn't given in the problem. You have to figure that out. So that means that she must have a 1-year-old, and that means that the sum has to be 20. It has to be 1, 9, and 10. So the answer is choice C. So you have to use a little bit of logical reasoning there. If she said no, then you would actually need to ask another question, because you know that she doesn't have a 1-year-old, so this could be wrong, but there's still two potential cases where you can have different ages. So you need to ask another follow-up. And because the census taker did not ask a follow-up, it can't be 16. It has to be 1, 9, and 10. Okay, and here is the summary for this page. Thank you everyone for joining me today. Enjoy the rest of the day, and I'll talk to you guys in the next one. All right, bye everyone.